Hello everyone, welcome to another Uiua programming video. We're taking a look at Advent of Code 2018 Day 1. Part 1 is extremely straightforward. Part 2 is a little more tricky. So let's start with the parsing as usual. So we basically need to take this list, and for part 1 we need to find the final result of applying all of these changes when starting from 0. And the test input is in this CSV list. The real input is in this new line separated list, but anyway, we can work around both of those formats. So in previous videos, I've used the partition parse by not equal to, and in this case it would be a comma, and this works fine, but because the test input is like this and the real input has the new lines, we can actually use unCSV here, and this will convert from a CSV string into an array, and it always returns a two-dimensional matrix, but in this case we can just flatten it since we only have one row, and then we can just parse the input. So then we have our numbers. And I'll use this one because, like I said, it will also work for the new line delimited, the real input. So with this, for part 1, we just need to add up all these numbers. So we can use the reduce modifier, which will apply a reducing function. So basically put the function in between all of the elements. And in this case, we want add. And that's literally the entirety of part 1. So part 2, like I said, is a bit more interesting. We're looking to find the first frequency that we reach twice. And it's important to note that the device may need to repeat the list of frequency changes many times. So let's just take this test input. We expect to reach the 10 twice. And we need a way to do this kind of plus reduction, but we need to keep the states that we've reached. And for that we can use scan, which is reduce but keep intermediate values. So that's exactly what we're looking for. And you can see here that we start at 0, we add 3 and go to 3, we add 3 and go to 6, add 4 and go to 10, etc. So the only problem now is that we don't have another 10. We didn't have enough input values. So how can we duplicate this original list that we have? For that, we can use a scalar reshape. So if you give reshape a scalar as its first argument, then it will copy the second argument as new rows of an array as many times as the scalar. So in this case, 2 will create an array of 2 rows of the original vector. And we can flatten it to get the vector with the repeats. And then we can do our plus scan, and now we see that we do indeed have the repeating tens. And how can we identify that this is the second occurrence of a 10? Well, we have occurrences, which marks each row of an array with its occurrence count. So if I do this, you'll see that all of these first 6 numbers corresponding to these first 6 are the 0th occurrence of these elements. And as soon as we get to the 7th element, the second 10, then we get our first 1 here to indicate that this is the second occurrence. And what we really care about is the first time a 1 appears in this occurrences array. So for that, we can use where. This will get us the indices where the array values are not 0. So in this case, it will return this 6 and this 9. And then we care about the first one, and then we just need to pick this 6th, or let's say 7th element, index position 6, out of the vector, and then we get our 10. So this is great, but it doesn't help that we don't know how many times we actually need to repeat the the vector to reach something. So in this case, we only needed two, but if we start working with our real input, I can just drag that in here. Where'd it go? So I can replace this with our real input. And now you see we're getting this error that it cannot take the first of an empty array. And that's because when we're doing this occurrence count, we're just getting all zeros. And when we call where on that, we get an empty array. And then when we're calling first, we're getting this error. And so this function fundamentally is fine as long as we give it enough of an input. So one thing we can do here is we can call this P2, but we can make it a dyadic function. So you can see it's now blue, meaning it needs two arguments. One argument is the input list, and the other argument is how many times to repeat it for this reshape. So then we can do something like put a 0, and we want to call it with 0, see if it errors, so we can like try, and then this is basically like how you catch an error and give it a default value, right? So it's like try p2, and if it errors, then return -1. So uh, we want to do something like this, but we want to not really have -1 back. We want to detect that it's -1, and then we want to do something like increment this number by 100 and try again. So we can use do for that. Repeat a function while a condition holds. So our condition can be that this is returning something less than 0. And you can see that this is true because it's erroring, it's returning -1, and then this is saying, yes, it is indeed less than 0. And in that case, what we want to do is we want to add 100. So now you can see that it stopped iterating at 200, which means that calling P2 with the value of 200 will not error. So we can simply call P2 now, and we'll get our value back. So this is a bit of, I don't know, like a little hacky, I guess. I'm not sure. We can just call this function f, and then P2 becomes this, and this needs to be here, and then we can do our usual thing and get both of our values. So yeah, detecting that it errors and incrementing the value we're testing until it doesn't error, and then sort of calling it. I don't know, maybe there's a better way, but I think this works pretty well, and it runs very quickly, so it's not really a problem. So anyway, that's everything. I hope you found it interesting and entertaining, and I will see you in the next one. Thanks for watching.